Good morning and welcome to the second session of the 5th International Symposium on Analytical Methods in Philately, sponsored by the Institute for Analytical Philately. Imagine that. We have today 5 more speakers. They are Thomas Lamb, Danny Brinkley, Tony Thompson, Majid Hosseini, and Bill Ullom, who will be presenting their papers over the course of the day today. Roughly an hour is allowed for each. I ask that you use the chat boxes if you are an attendee. I don't believe the Q&A is available to you, but whichever one, Q&A or chat, we'll keep an eye on that and we'll ask questions at the end, time permitting, of each presentation. I will ask that all the presenters remain muted unless they are speaking, and we do have backup for Thomas in case somebody asks a question that one of his co-authors can answer more readily than he can. We are not recording Thomas's presentation at the request of the National Postal Museum. However, we will record the remainder of the session once he is finished. So let me start out by pausing the recording. Okay, Thomas, thank you again very much for your presentation, and Scott for your assistance answering questions. We will start Danny Brinkley's presentation about 3 minutes after the hour, just to give everybody a quick break to stand up and stretch their legs, and then we'll get back on it. I'll introduce him at that time. Thomas's presentation will be posted as a PDF on our website sometime when we get all the rest of the presentations up and we load the video as well. So in addition to the materials that you see in his published article, his presentation will be available online also. With that, I'm going to pause things, and Danny will be back in 2 or 3 minutes. Let's do that. Good morning again. I got a note from John Cebulskis. He correctly points out that on page 68 of the proceedings, which lists the references for Thomas Lamb's paper, we unfortunately misspelled John's name. However, I think if you get that much of it typed in, you'll probably be able to find it online. Our second speaker today is Danny Brinkley, who was born in Lexington, North Carolina in 1957. He and I exchanged some emails about that. He attended North Carolina State University, earning a Bachelor of Science and Master's degree in Material Science and Engineering. Danny holds a professional engineering license in North Carolina and has over 40 years of experience in engineering investigations related to material and mechanical failures or problems and electrical device failures. He has extensive materials characterization experience involving SEM, EDS, XRD, XRF, and so on. Danny started collecting stamps as a boy and returned to his collection in the late 1990s. Since then, he's developed an interest in the 1851 3-cent stamp. Due to a question about the various papers used to print these stamps, he examined one of the 1851 3-cent stamps with a scanning electron microscope and has continued studying these stamps with his instrument as time permits. And we see that as his article, and we're about to hear more about it. Danny, please go ahead.
Okay. Good morning. Thanks for the introduction, Ken. Hopefully you can hear me okay. I'm going to do a presentation on the examination of some U.S. 1851 3-cent stamps from Plate 1 in its early state. So why Plate 1E stamps? And I guess this is just a brief outline of what I'm going to cover. A brief discussion on environmental scanning electron microscopes, how you can examine electrically non-conductive specimens without altering them, some of the interactions with the instrument electron beam with the sample, generation of images, generation of characteristic X-rays. We're going to discuss color variations, some usage states based on cancellations, results, and then discussions and conclusions. So why examine stamps from Plate 1 in its early state? So Topin, Carpenter, Kessler and Company was awarded the contract to produce these stamps in March of 1851. And the first plate created was Plate 1 in its early state, which was like mid-June. So this plate was in use until about mid-July. And that's basically determined because of the use of Plate 1 stamps in its intermediate state. Its earliest known use is July 12th, 1851. So basically, Plate 1 had the impressions re-entered with the die or the roller, basically to create Plate 1 in its intermediate states. So for that 4 weeks that the stamp was printed from Plate 1 in its early state, there are several recognized color variations. An orange-brown from pale to dark, pale yellowish orange-brown, which is known as the first printing, yellowish orange-browns, bright orange-browns, and reddish orange-browns. So the printer had no prior experience with printing stamps. They had made banknotes prior to this. Could they make a profit from printing these stamps? So here's an illustration of the instrument. So this is the Hitachi S3700N, and basically you can see the X-ray detector here, the column, the beam source up here, and then the specimens down here. The actual specimen is shown inside the chamber here. So the stamp is actually located on top of this substrate. The back scattered electron detector here, the beam comes down through this conical column, the X-ray detector here, and then secondary electron detectors here. So at each point as the beam strikes the sample, there are all these interactions where the beam comes down, as shown by the green arrow, and get all these signals depending on whether or not you have detectors to capture those signals. And this presentation is mostly going to talk about characteristic X-rays, which is detected by this detector, and backscattered electrons, which are detected by this detector. So scanning electron microscope, the electron beam rasters over the sample in like a matrix. So in the case of the X-ray maps that will be shown later on, we're talking about about 2,500 points per row by 18, almost 1,900 rows. So at each point, the beam will be at one location, then move to the next location, and so on, creating like a field of view. And at each point along this location, the beam is interacting with the specimen, and we're capturing any of these signals we want to. So the X-ray maps that are shown in this presentation were collected for about 90 seconds each scan. So the general action with and again, using kind of the Bohr model for an atom, got the nucleus and the different electron shells. And so the primary electron beam from the instrument comes in. The inelastically scattered electrons basically are your backscattered, or I'm sorry, the elastically scattered are your backscatter signal. And then you've got like what's known as just the deceleration of the X-ray, giving off characteristic background radiation. So every so often, one of the beam electrons will come in, knock out an inner shell electron from the nucleus of an atom. And that's an unstable configuration. So an electron from an outer shell drops into an inner shell. The energy difference between those shells is compensated by an X-ray being given off. And if you've got the detector, you can detect what those X-rays are. The image to the right here shows basically all of the different electron interactions that could occur depending on which atom or which chemical element you're looking at. So you start with the K shell electrons, go to the L shell, M shell, and that's typically all you're detecting with the EDS system. So here's an example spectrum obtained from a 3-cent stamp, which shows this is actually a red cancellation on an 1851 3-cent stamp. So you can see basically the cancellation and then the ink of the stamp. So we show basically peaks for lead, mercury, sulfur, chromium, copper, and then oxygen and carbon down here. So I've shown an expanded scale of this larger peak here at this location, and then basically the characteristic X-ray lines for the different elements. So you can see that you've got several lines in here for mercury, which are shown as like cyan, sulfur as green, and then the magenta color as lead. So all of these X-rays from these three elements overlap one another here. And so you get this broad peak here. And usually the software of the EDS system can deconvolute these X-rays to give you rough idea of what the concentrations are. But these all overlap. So if you're mapping sulfur and you have lead present, there will be lead X-rays showing up in your X-ray map. And the same thing for mercury to some extent. Now, showing like the right-hand portion of the spectrum, you can see there's like delineation between where the L shell electrons show up. So you can see the mercury lines are distinctly separate from the lead lines. So when you're mapping and when you're quantifying X-rays from mercury and lead, you're typically using these peaks and not that peak. So here's a backscatter image of a copper grid and a nickel grid on an aluminum substrate. And I've used like a graphite paint to attach these to the aluminum stub. So again, if you look, and again, maybe it's my imagination, but it looks like the copper is slightly brighter than the nickel, and that's only one atomic number difference between the two elements. But you can see the difference gray level between the aluminum, the copper, the nickel, and then the graphite. So here are 6 images showing, again, one of the 3-cent stamps. So again, you can see the back of Washington's head here, the oval, the tessellated design to the right, and then the frame lines. This is a secondary electron image and a backscattered electron image at high vacuum. This is a backscattered image at a variable pressure mode, which basically eliminates the charging effect of these non-conductive materials. So you can see the secondary image, you see these black areas, which are artifacts from the beam interacting with the specimen. The backscatter image looks fine, pretty much the same as the backscatter image at variable pressure. But at higher magnifications, you can see the distortion of the image in the secondary image, and especially on the backscatter image as the beam concentrates in a smaller area. Whereas in the variable pressure mode here, with like about 50 pascals partial pressure in the chamber, there's no charging effect. So this is basically the same stamp shown at 50x. And it fades into 100x. 250x, 500x. So you're beginning to see how the color of the stamp or the image changes as you increase magnification to 1000x, to 2500x. And again, these are backscatter images and variable pressure. And this final image will be the same image shown previously, but this is like the variable pressure mode of a secondary electron image. So you can actually see the topography of the ink pigment at that location, which this is the only time this will be illustrated in this paper. So this example here shows the stamp. We collect an X-ray spectrum from here, and this shows the basic composition of that stamp. I show numbers down here for the concentrations of various elements, but these are just ballpark numbers to give you a rough idea of the composition. The EDS technique really requires a homogeneous sample, and this is obviously not a homogeneous material. So the next image here shows like X-ray maps. So again, at lower magnification, 50x, and at 2500 times magnification. So you can see the different maps for each one of these, the cyan being oxygen, the red being lead, the orange being iron, the white calcium, and the green silicon. So you can show like the distribution at lower magnifications, but you don't really begin to see how these elements are distributed in the pigment until you get to much higher magnifications. So the 4 stamps used in this study, these are all plate 1 in its early state, a yellowish orange brown here, an ordinary orange brown here with a magenta cancellation, a pale yellowish orange brown, which is known as the first printing, and then a bright orange brown. So the backscattered image here, this shows all 4 stamps on the same substrate in the electron microscope. And you can see that there are obvious differences in the signal between the 4 stamps. So this is like the least bright stamp, and this is the most bright stamp. So again, the brightness of the image here is a function of the average atomic number of the ink or the pigment or the specimen you're looking at. So in this case, this stamp, which is the bright orange brown, appears to have a higher average atomic number than does the yellowish orange brown stamp. So the first stamp, the yellowish orange brown, looking at one area of that stamp. So this is basically what the ink pigment looks like at 1500x. So 1500x will be used throughout this presentation, since it seems to show enough detail of the stamps. And then an X-ray spectrum showing the elemental composition of this area within the red box. So again, this pigment shows the primary color. It probably is iron and calcium. So again, you see the presence of calcium, oxygen, sulfur lead here, not much of a lead peak out here. This shows the X-ray maps associated with that same area. So again, a backscattered electron image here in the top left, lead map in the center top, oxygen in the center right, calcium at the lower left, iron at the center and the bottom, and then silicon at the bottom right. So again, if you look at the concentrations, most of this image, which is the higher atomic number material, is associated with iron. There are concentrations of calcium present. There are concentrations of oxygen and concentrations of silicon. And some of these will show up together. So the next image here shows the backscatter electron image, superimpose an oxygen map over the backscatter image, take away the backscatter electron image, go back to the backscattered electron image, superimpose the sulfur map over this, which is not shown in the previous slide. So again, bear in mind that if there's any lead present, this could account for lead being present at this location due to the overlap between sulfur and lead. Add in calcium, then combine calcium and sulfur together. This shows like there's some concentrations here where sulfur and calcium show up together and some where it's just calcium by itself, suggesting there are two different types of calcium compounds used in the pigment. So one probably being a calcium sulfate, the other possibly being calcium carbonate. Backscatter image again, add in the iron concentration, take away the backscatter image to show the iron distribution, and on to the next stamp. So this is the ordinary orange-brown stamp with the magenta cancellation. So the significance of the magenta cancellation, according to most experts, is that this was used during like the first week in July when this stamp was officially used or designated for use by the postal system. So this would date the stamp probably to the first week or so of July in 1851. So again, an area at higher magnification, 1500 times magnification, and then an X-ray spectrum showing the composition of the ink. So again, this shows much higher concentrations of lead, lower concentrations of iron and calcium, and then basically silicon, calcium, oxygen, and carbon. Here are the X-ray maps from that area showing the distributions of the different elements. So basically lead at the top center, oxygen, calcium, iron, and silicon. So again, the lead appears to be associated with these brighter areas that have an average higher atomic number compared to the background based on the backscatter electron image. You can see like the calcium concentrations in here as well. So here's the backscatter image, and then bringing up the X-ray oxygen map, and then the silicon map. Okay, the backscatter image again, the lead X-ray map, take away the backscatter image to show the lead concentrations correspond to the bright areas, add in the iron, add in the silicon, add in the calcium to show basically rough idea of what the pigment consists of and the distribution of the different elements in that pigment. So again, the size of the areas, you can get a rough feel for. The micron marker shown at the bottom right is 20 microns. Take away the calcium and the lead, And this shows like the silicon and the iron concentrations. Add in the oxygen. And onto the pale yellowish orange brown or first printing. So this has like the small Boston paid cancellation. Again, the pigment at backscattered image at 1500 times magnification, the relative composition of the area within the red box shows basically the presence of lead, calcium, much smaller concentration of iron, carbon, oxygen, silicon, and magnesium and aluminum. The X-ray maps, so again, showing the backscatter image, the lead map, the oxygen map, calcium, iron, and silicon. So the one thing from the get-go on this image is the concentration of the calcium in this stamp compared to the previous ones. So the backscatter electron image, the lead X-ray map superimposed over the backscattered image, take away the backscatter image to show the distribution of lead, add in the calcium, add in the silicon, and add in the iron. So again, from this map, there's only like trace amounts of lead, I'm sorry, iron present. So the pigment, the colorant in this ink appears to be mostly due to the presence of lead and calcium. Take away the lead, and you barely see any orange in this distribution to show the presence of iron. Take away the calcium, and this shows like the iron and silicon distribution. The next stamp is the bright orange brown, has a red grid cancellation. Here's the backscattered image of the ink pigment, and then the elemental composition of that pigment in the red box. So again, a lot of iron, calcium, iron, I'm sorry, a lot of lead, calcium, iron, silicon, oxygen, carbon, and aluminum. Here's the backscatter image, the lead distribution, oxygen, silicon, iron, and calcium. So this is much less calcium present compared to the previous stamp, the pale yellowish orange brown. So the backscattered image, and superimpose the lead X-ray map over that, which generally corresponds to the brighter areas in the backscatter image. Take away the backscatter image to show the lead concentration. Add in the iron. Add in the silicon. Add in the calcium. And onto the next stamp. So this is a stamp expertized as coming from plate 1 in an intermediate state. It has a red small Boston paid cancellation, which would indicate it was used in July. So this would be an early use of the plate 1 in its intermediate state. So again, the backscattered image showing the general composition of this ink pigment, and then the X-ray, elemental X-rays for the pigment in the red box, which shows, again, plenty of lead there, iron, calcium, silicon, aluminum, oxygen, and carbon, and a few other elements. Okay, the backscattered image with the X-ray map. So again, lead, oxygen, calcium, iron, silicon. Again, the calcium's not as high a concentration as it was in the pale yellowish orange brown stamp. Going to the backscatter image, superimpose the lead X-ray map over the backscatter image. Take away the backscatter image to show the lead distribution. add in the iron, add in the silicon, add in the calcium to show basically the distribution of the different elements in the pigment. And throwing in the aluminum map for this, which is not shown for any of the other stamps. But again, this particular stamp showed a fair concentration of aluminum in this pigment. Finally, an analysis of the red cancellation out in the margin of this stamp. So again, the 1500 magnification image, backscatter image of the ink pigment or the cancellation pigment. So again, you can see like this consists of a fairly high concentration of a higher average atomic number element. And basically the elemental composition of that X-ray map, based on where that spot is on that particular particle, shows it consists of mercury and sulfur, or mercuric sulfide, or vermilion. So again, Chase had speculated that vermilion was used in the pigment of the inks used to print these stamps, but Thomas Lear and Jim Allen and others have shown basically there's no vermilion used in any of the ink pigments used to print these stamps. However, it was used in the cancellation inks. So several other stamps which aren't illustrated in this paper were analyzed. And again, there are two that are the pale orange-brown, yellowish orange-brown first printing. And again, they show the pigments to be primarily just lead and calcium. So there's agreement there between those two. The yellowish orange-brown stamps and those printed on part India paper tend to show iron to be the primary pigment in the ink used to print these stamps. And then the ordinary orange browns and others basically show the use of lead, iron, and calcium. There are other ordinary orange brown stamps that were looked at that have high iron concentrations, although they're not yellowish orange browns and they're not on part India paper. So again, the composition of the ink pigments don't necessarily correlate to the different colors. So in summary, the 1851 3-cent stamps from plate 1 is in its early stage were printed from about mid-June to early July for a duration of probably less than 6 weeks, probably less than 4 weeks. The earliest known use of plate 1 stamps, July 1st, 1851. Postmarks on these stamps show they were used as late as October 1851. Earliest known use of plate 1 in its intermediate state is July 12th, 1851, meaning that something happened to plate 1. Was it wear or something else, requiring the dye impressions to be re-entered on plate 1 prior to this date to create plate 1 in its intermediate state. Several recognized orange-brown shades for plate 1 early stamps: orange-brown, pale yellowish orange-brown, or the first printing, yellowish orange-brown, bright orange-brown, reddish orange-brown. And based on this study, the pigments used for the plate 1 early stamps are varying mixtures of iron-based, lead-based compounds with calcium-based extenders. The analysis technique used for this study, the SEM-EDS method, identifies the elements present but not the chemical compound. So there are general concentrations of specific elements associated with some of the shades. So the first printing, pale yellowish orange-brown pigment, consisted of a mixture of lead and calcium compounds with lesser amounts of an iron compound. So correspondence from the U.S. Post Office, and again, this was uncovered by Wilson Hume, I guess, in the Travers Papers, which are now maintained by the United States Postal Classics Society, stated that this color shade, this is correspondence from the post office to the printer, stated that this color will not stand and was discontinued. But it is only known with plate 1 in its early state stamps and they were used for postage. The yellowish orange-brown pigments consisted primarily of iron compounds with only trace amounts of lead and calcium compounds. All of the Part India paper stamps used the same type of iron-rich pigment. The ordinary orange-brown and bright orange-brown pigments consisted primarily of lead compounds with varying amounts of iron compounds and calcium compounds as secondary colorants. Some ordinary orange-brown stamps have a pigment that consists primarily of iron compounds with trace amounts of lead and calcium compounds, similar to the yellowish orange-brown stamps. The variation in pigments compositions used for the Plate 1 early stamps suggests that Taupin, Carpenter, and Casalier were experimenting with their formulations. The pigment used for an early Plate 1 in its intermediate stamp, the pigment for an early use Plate 1 intermediate plate stamp was very similar to the Plate 1 early state ordinary orange-brown and bright orange-brown shades. This could indicate that Taupin, Carpenter, and Casalier and Company had settled on a general formula for the 1851 3-cent stamp ink for the type 10 and 10A stamps. The reddish iron oxides, hematite or Venetian red, are also known as jeweler's rouge, which has been used as an abrasive. It has been theorized by several people, Jim Allen and Gary Grasnow, that this pigment probably led to excessive wear to plates 1 in its early state, plates 1 in its intermediate state, plate 2 in its early state, plate 5 in its early state, and plate 0. So future work. So the study showed that the pale yellowish orange-brown shade contains significantly higher concentrations of a calcium-based extenders. So correlation between the other shades and colors and their compositions was less apparent. So a logical next step in this investigation would be quantifying the area fraction of the different mineral phases present in the different shades to see if there's a correlation. So one reason probably the different, I guess all the experimentation with the different pigments used to print these stamps is the cost of the pigments used to make the ink. So based on 2022 prices, I've listed some materials that I have purchased for analysis. So mercuric sulfide or vermilion at $20 for a 5-gram sample, lead chromate or Paris yellow and other shades, $20 per pound, lead oxide or minimum, which is also known as Paris or Saturn red, about $20 per pound, yellow iron oxide, which is basically iron oxide hydroxide, about $4 a pound, iron oxide Venetian red or hematite, $1 to $4 per pound, calcium sulfate, plaster of Paris, about 50 cents a pound, and calcium carbonate, about 20 cents a pound. And in the slide shown here, you can see the lead chromate here, the yellow iron oxide or iron oxide hydroxide, 3 different shades of hematite, and then basically magnetite or Fe3O4. Now, I don't think they've ever used this in the pigments, but it's primarily these guys right here. And I guess thanks to the IEP for hosting the presentation, and thanks to Ken and Tom for reviewing the paper. Thanks to the APS Expertizing Service. Thanks to the USPCS, Jim Allen, Charles Temple, Dick Seller, Elliot Amaya, Wilson Hume, Dr. Wilbur Armanet, and Gary Grasnow for their publications in the Chronicle. Chuck Mooney, a local engineer who's consulted on with electron microscopy, and to my company, Accident Reconstruction Analysis. Questions or comments?
Yeah, I've got some hands up here and a couple of questions for you, Danny.
Okay.
I'm going to start with what I think is an easy one from me, and that is when we're looking at a 1500x image on the slides or in the published paper, are we seeing little granules, little dust size pieces of lead or iron or whatever it might be in the pigment?
Yes.
Okay.
So I
Thank you.
think that the thing is like Jim Allen has well, I've communicated some with Jim Allen, and he's I think worked in the polymer and paint industry for a long time and understands the creation of these pigments better than I do. But I think he indicates it's like a matter of how you blend these different pigments and the particle size that affects the color to some extent.
Okay. Among our presenters here, I've got Russ Sampson with his hand up. Russ?
Yes, very good presentation. Loved it. Danny, do you know what the printing plates were made of? Were they a iron compound or a copper compound?
Well, Gary Grasnow has done a lot of research on that and published several papers and a book. They were using basically steel that was created at that time. So there's a lot of I've began to kind of scratch the surface because one of the things that Gary Grasnow and Jim Allen discuss is whether or not these plates were heat treated. So ordinary carbon steels, depending on the carbon content, can be heat treated to increase their hardness. So
yes, my question.
Sorry.
I have two questions. That's my first one. So my second one is I know that the quality of steel in the early 1860s was rather low and very experimental. They hadn't advanced very far. And you talk in your paper, and you mentioned at the very end of your conclusion that there was concerns about plate wear. And so because it appears that iron is one of the more variable elemental components of the pigments or the inks that you're analyzing, has there been any work to show what levels of contamination of iron could originate from the wear of the plate that would go, the printing plate that would go into the ink? And so I'm trying to put myself back in the 1860s. It's July. There's no air conditioning. You have poor quality steel, and you've taken the weekend off, and you come back, and there's the plate rusty.
Yeah, well, that would certainly form iron oxide or hematite. So that's a possibility, but I don't know of any research into that.
Yeah, I just wonder if there is a way of looking for evidence that would delineate between the pigment iron and the iron that would come from the plate.
So I think one thing based on the SEM examination, and again, the question would be whether or not the iron oxidizes or whether it's like would be present as like metallic particles. So obviously the metallic particles would give you a brighter image than would the iron oxide in the backscatter image. But again, if you're getting wear, again, based on the surface area of the smaller particles, you would guess that it probably would oxidize rather than remain as basically iron rich particles.
Right. Okay. Thank you.
Yep.
Sorry, I was muted. John, Barwis, you've got a question.
Yes, that was a great presentation, Danny. My question was, I noticed that little chunks of silica in a lot of your images. I'm assuming that those are just pieces of quartz that are contaminants introduced in the mining process. Is that reasonable, or is there another reason why there's quartz in there?
No, I would think that would be the most reasonable explanation. The other thing could be used as like some grinding media. So whatever they mix these pigments up in. Again, I don't know if they use ceramic containers or metal containers, but you could argue it could be introduced from the containers the inks were mixed in as well. And
Hadn't
again,
thought of that.
yeah, if you got like a mortar and pestle, so you're trying to grind a particulate size to a fine size to make a better ink, yeah, could be from that as well.
Thanks, Danny.
Yep, my pleasure.
Thanks, John. Next up, I've got Joe Bowling, and he's got a whole bunch of stuff, including a comment on the heat treating. Joe.
Well, first, you were looking at, very small sections of a stamp. Did you look at several sections of the same stamp to test for uniformity of mixing of these components of the inks?
Can you repeat that now?
Did you look at several areas on the same stamp to
Yes,
test
yes,
for uniformity of mixing?
yes.
Okay,
So generally, I tried to stay away from cancellations.
right.
And areas where the ink was like a higher concentration, like in the upper lower levels in our labels, sorry.
Okay, next, please explain what part India paper is.
I guess I can't actually offer you a good definition for that. Supposedly, from what I've read in Chase's book and others, is that it's basically a mixture that used some degree of bamboo fiber in the making of the paper, and it generally has a much smaller thickness compared to ordinary, I guess, cellulosic papers made at that time.
Okay, yeah, I'm familiar with India paper for proofs. I just never heard it called part India. All right, third item was that you can't re-enter a heat-treated plate. A heat-treated plate, is a hardened plate, and it can't be re-entered. So those, if they were re-entering the plates, they were not heat-treating them.
Yeah,
National banknotes had the same issue. The national banknotes were printed from unheat-treated plates because if a bank title changed, they wanted to just change that part of the plate and not have to manufacture a complete new plate.
yeah. No disagreement whatsoever. So the steel would have to be in its like unhardened condition in order to be able to re-enter those impressions. But people have suggested, they probably weren't heat treated or hardened to begin with, that they may have hardened them later on. So plate 1 in its late state, plate 2 in its late state, plate 5 in its late state, 4, 6, 7, 5 in its late state, 7 and 8. Those may have been heat treated, but there's no way we'll ever know. I mean, everything was destroyed. Be one of those things would be really great to have a sample of one of those plates.
Okay, thank you.
All right, Louis, I got you up next.
Thank you. I have 3 related questions. The first one is, where did these stamps that you analyzed come from? The second one and the third one are related. They have to do with the printer, Tobin, Carpenter, and Cavalier. They had been printing banknotes, you said, and my ignorance in the printing process and the paper used makes me ask, how different was it for them to use ink to prepare ink formulas for paper notes as opposed to paper stamps? And finally, these stamps were reissued, a new printing in 1857, same colors. Was Tobin, Carpenter, and Cavalier still contracted to make those, or was a different company contracted?
Yeah, so I can answer the last question. That's the easy one. So TCC and C basically continued to make the stamps in 1857. They lost the contract in 1861. So again, the perforated stamps in 1857 were still printed by TC and C. The next question about where they came from, I'm not sure exactly what you're asking there. I mean, I got these stamps at auctions, and based on just personal curiosity, spent a lot of money sending them off to get them expertized, because I didn't really at the time understand the difference between plate or the 10s, 10As, 11s, and 11As. And you know, the colors were obviously different. So I spent a lot of money getting them expertized.
Right. I didn't realize they were part of your collection.
Yes.
Okay.
I doubt
And
people would let me look at their stamps.
well, maybe not. And then the other question had to do with the transition of printing banknotes to printing stamps. What is fundamentally different that they would have had to experiment with a variety of printing inks?
So the plates for the stamps were like a 10 by 10 matrix, and like two of those on a single plate. So you had 200 impressions on a single plate. Whereas I think the banknotes were either like single items they printed, or a much smaller number of impressions each time it was, you know, like a sheet of paper was printed with the design.
All
So
right.
they're taking a much smaller design, whereas, you know, most banknotes were probably like 10 times the size of this postage stamp.
Yeah. Okay.
So
But the inks would have been different then. Is it because the paper was different?
well, I think they were printing fewer banknotes than they were printing stamps, because by the time it was all said and done, I think they printed close to 2 billion of these 3-cent stamps. So I think Gordon Eubanks did a presentation for the Royal Philatelic Association some time ago, talking about how the issuance of these stamps and the use of these stamps apparently increased the demand for them. So the printer was actually having a lot of trouble keeping up with demand those early years of printing these stamps.
Got it. All right. Thank you.
Joe Bowling offered a comment that the banknotes were printed 4 to a sheet.
Okay. Thank you.
You're welcome. Thank you.
Next up, Frankie.
Hello, thank you so much for the fascinating talk, Danny. I was curious about the working distance for the elemental maps, as well as why you chose 1500 magnification for mapping. If this was answered previously, I'm sorry, it could have been on a slide. I just didn't catch.
Yeah, well, it would show it on the images. I was using right around 10 millimeter working distance. So each, with the Peltier cooled X-ray detectors, apparently the working distance is much more sensitive than with the older liquid nitrogen cooled detectors. So again, 10 millimeters for this instrument is like the ideal working distance for doing X-ray work. The 1500 times magnification seemed to show the structure of the different, I guess, particles in the ink pigment better. And I just tried to stay consistent between one image to the next. So just settled on 1500 times magnification.
Thank you so much.
Yep. I mean, I've done them at higher magnification. I've done them at lower magnifications, and seemed like the 1500 shows the most.
Gotcha. Thanks.
All right. Rick Anderson.
Can you hear me?
Yes.
Yep.
Okay. Thank you for the presentation. Takes me back to my failure analysis days using an SEM and trying to analyze the features. Primary question I had was, you'd indicated you tried to stay away from the cancellations. Are you able to discern the difference in cancellation inks versus the printing inks? And,
Yes.
and what is that difference?
Well, most of the red cancellations that I've looked at are basically vermilion or mercuric sulfide. The black inks typically are carbon black, primarily is the primary pigment in those. So they actually are almost transparent to the backscatter image, at least at 20,000 volts accelerating potential. So you can actually see most of the stamp design through a black cancellation. The other cancellations I looked at are yellow and greens and blues. And those vary, and I guess actually an orange. Those actually vary in composition as well.
Okay. So you cannot see through the vermilion cancellations? I mean, I recognize the carbon black issue. But the vermilion will be more obvious. Obviously,
Can you
it's going to
speak
have a
up,
higher
please?
atomic number.
He's asking whether or not the vermilion is more translucent than the
No.
black.
I mean, that vermilion cancellation actually is an extremely high concentration of particulate. So it's almost like pure vermilion, maybe mixed in with whatever agent they use, whether it's linseed oil or which I assume it is. But it's extremely high concentration of particulate.
Okay, thank you very much.
Yep.
Right. Wait a minute. I forgot to set up our next questioner here. Richard Rona, you are up.
Thank you for a very interesting presentation. What regard to the 4 colored stamps that you showed, who expertised them as to color?
That's a good question. I mean, they were sent to the APS, so I would assume maybe some of the early ones probably involved Dr. Ahmad. Some of the later ones would have been obviously Charles Temple and others. But I mean, the expertizing sheets never identify who identifies the colors. Now, I have sent individual stamps to Charles Temple for his opinion.
Okay, thank you very much.
Yep.
All right. And Joe Bowling again offered a comment that most of the banknotes in the mid 1850s were black. So the reason for experimental inks was we were asking for stamps in different colors.
Okay, thanks.
And that is the last question in the queue. We have a few minutes before we start the next presentation. Actually, we're going to wait until 12:15 Eastern Daylight Time. And we will reconvene then when Tony Thompson will address the group again about Newfoundland stamps. So, Danny, thank you very much. And thanks again to our participants and for the people who have asked questions. Gary Lowe just pinged me and said, when I was director of expertizing at the APS, that would have been, Charles was doing the colors on US 10s and 11s.
Okay.
All right. We will see everybody back here at 12:15, which is about 18 minutes, I believe. Thanks again, Danny. All right, we have turned the recording back on. Our next speaker this afternoon, Eastern Time, is Tony Thompson. And you heard his bio last week, but it's short enough, I'm going to present it again. Tony started recollecting stamps in 2003 when he moved to Halifax, Nova Scotia to work with Northwest Atlantic Fisheries Organization. Naturally, his collecting interests centered around the cod stamps of Newfoundland. He did well on one-frame exhibits in Canada, winning golds, but moved to Sweden in 2010, which is where he sits today, where the interest in Newfoundland exhibits was less than tepid, and he stopped exhibiting. Tony enjoys writing articles of an analytical and scientific nature and received the BNAP's Vincent G. Green Award in 2013 and 2021, and the CCC Colonel Platt Award in 2011, 13, 18, 20, and 2021. All of these are for articles in BNA topics. His interests outside of philately include cycling, extreme macro photography, and bird watching. So with that said, Tony, you are up.
Thank you, Ken. Let me get myself started. Share screen. Share. And share the presentation, which has disappeared. Okay, I only do this every day.
There we are.
That's partly it. Do you see presenters or?
We're seeing the screen where you see the advanced slide in the upper right corner.
Right, let me just swap that around. Is that better?
There we go.
It's amazing. You do this almost every day through work, and then you come to do it for your hobby and it all goes wrong. Anyway, here we go. This is a talk to use some of the analytical techniques that have been described in IAP over the last several years now, to see if we can find a difference between two Newfoundland stamps. And I must say, I'm very much indebted to Richard Judge for encouraging me to undertake this work. And he very kindly undertook some of the more, some of the analyses that required specialist equipment. And I'm hoping the talk isn't too much above my own head now, but if I do struggle, I might have to resort to Richard for clarifications. So these are the stamps in question. It was printed by Bradbury Wilkinson in New Malden, England, and it was issued in Newfoundland on the 17th of June, 1939. So a very modest stamp compared with those that we've been presented with so far. But there are incredibly interesting facets even to ordinary stamps. This was overprinted in St. John's, Newfoundland on the 20th November to make up for shortages in the regular issue. And you see the two overprints on the right, the 2 cents in a brown color and the 4 cents in a red color. Just to clarify the nomenclature a tiny bit, the uninked area around the stamp is known as a selvage. And this is an area that I use, well, I'm going to say we use because Richard did a lot of this. We used to look at the signals from the paper only regions. Now, this is the aniline stamp, and it was reported to occur. And aniline ink seems a funny thing. Originally, it was defined as a color that was derived from coal tar, and it tended to bleed around the lines. So if you look closely at the actual face of the stamp on the left, you can see all the white areas have a blue tinge to them where the blue ink has bled into the white. And then if you look at the back of the stamp, you can see a very clear impression on the back. And more recently, Stanley Gibbons at least have amended their definition to being any stamp that is particularly bright in its color and where the ink is shows on the back of the stamp. This stamp is quite interesting in that the aniline variety, which you can buy now, and it usually costs $200 or $300 Canadian dollars, 200 American dollars, compared to the regular stamp, which is a few dollars. So the aniline varieties are not listed in the major stamp catalogues. Scott, well, from 1946 to the present day, or Stanley Gibbons do not recognize an aniline stamp. The stamp was first listed in the Newfoundland Specialized Stamp Catalogue in 1992, in the first edition in 1998. You don't see it. And John Walsh and Robin Moore first found this stamp at a show in 1991. And you see here the arrows to indicate that an aniline stamp was found and worthy of including in their catalogue from 1992. And the aniline stamp was found in the regular printing and the 2 overprints. And that is quite significant, and we'll discuss that more later. So the question that I was trying to answer was, is the aniline variety a genuine stamp in that it was made from a different ink, paper, or method, etc.? It was printed by Bradbury Wilkinson in 1939, and it was offered as a stamp for sale in Newfoundland. Scott and Stanley Gibbons are particularly keen only really to show stamps that were offered for sale and hence entered into the postal system and could be found really used. The other option for this aniline variety is that it's a changeling. It's something that happened post-production. And this could be stored in or bad or poor quality plastic mounts, which can cause certain inks to effectively dissolve, or under poor conditions, exposure to certain chemicals, etc. So that is the question that this study tries to answer. As far as the material examined goes, lots of normal 5 cents, 2 cents, and 4 cents overprint stamps were available, mint and used, and probably some 50 different stamps were analyzed during this study. But I had only one block of the red surcharged aniline stamp, which I bought in 2019 for 210 Canadian dollars. That actually was a really good buy, I think. I presented a paper last week that looked at the red, green, and blue analysis, the color of the regular stamp and the aniline stamp. And the quick summary of that presentation was that if you actually analyze the color of the ink, they are remarkably similar. But if you look at the 2 stamps, the aniline stamp appears both lighter and brighter. And that is because of the blue ink diffusing into the white paper, gives it a very different impression. And again, there was another excellent talk last week about the shades of paper really affecting our visual perception of the colors. And that can't be overemphasized enough, that the background does affect our impression. This paper is going to look through this 8 or 9 different aspects: visual inspection, light microscopy, fibers, chemical treatments, reflectance spectroscopy, emission, X-ray, and Fourier transform spectroscophies. The last 3 of those are the aspects where I'm indebted to Richard for his help. So this is a visual inspection of the normal and the aniline stamps. The normal stamps were printed in blue. The image doesn't go through to the black back. There's no obvious bleeding. And here the surcharge, this is the red surcharge on the 4 cent stamp, appears bright red. On the aniline stamp, they're again blue, but they look different. They actually look brighter. I'm not convinced this one does look brighter on this slide, but they certainly look different, and they do look brighter. They're also quite hard to match up a color to. If you use a Stanley Gibbons color key, the stamps on the left, the normal stamps, are quite easy to match up to a color. The aniline stamp with a different background is somewhat different. It bleeds through to the back And surprisingly, the red surcharge has this discoloration where the blue ink has bled into it. It's very marked. Under a higher magnification, the normal stamp looks quite sharp, the blue looks blue, and the white looks white. The aniline stamp, you very clearly see this blue bleeding of ink, and the paper becomes a bluish color. And one of the catalogues can refer to aniline stamps as printed on a bluish paper. And then again, the surcharge magnified, showing this very odd discoloration. Just kind of playing with these stamps a little bit. Just a bit of chemical treatment. Hydrochloric acid, it reacts very strongly with calcium carbonate, which can be used as an extender, or it can be used in the paper as a filler. And here we very clearly see that the bubbles are coming from the ink and not the paper. So something in that ink is causing a reaction, liberating bubbles, and that's almost certainly calcium carbonate, and the bubbles are carbon dioxide, but not in the paper. This is where a little bit of the fun started, and I had several discussions with colleagues as to whether I should show and admit to this. This is a chemical treatment of a normal stamp, the one above, and then the one below after 2 hours exposure to acetone vapor. And what you very clearly see is that I've actually made an aniline stamp. So this doesn't really tell you whether the original stamps were not genuine or not. It just tells you that this ink is prone to bleeding, even after a very, very simple treatment with a very, very common solvent. This was a kind of unexpected finding, and I'm still uncertain as to the significance of this finding. If you look at the microscopes of the microscope pictures of the stamp on the left and the higher magnification one, the fibers have a much more open appearance. And when you do some elemental analysis, you see that the paper contains barium, probably barium sulfate. When you go to the stamp on the right, and this is a normal stamp, it's not the aniline stamp, it's a normal stamp, you see the paper is much fuller. There's not a lot of these loose air spaces in it. And when you do the elemental analysis, you see it contains both barium and titanium. And this was probably titanium oxide, which is a whitener, which makes the whole stamp look brighter because the paper can look brighter. This stamp was a royal visit to Newfoundland, and the whole stamp has a very regal opinion to it. And I think it's quite possible that they really wanted to have this brighter paper. As far as we know, there was only one printing of this stamp. So the two different papers are perhaps a surprise, or perhaps they used up a batch. I don't know, but I think there's only one printing of it. It was never reissued in Newfoundland. It was all sold on a single date. When you look under a light microscope, you can see on the left at well, a lower power, and these are just the stamp fibers teased out in water and viewed on a slide. At times 1,000 under oil immersion, you can start to see very small dots in the barium and titanium paper. And these little black dots are the titanium oxide. When you do an analysis, you find that about 75% of the normal stamps are on the titanium and barium paper. But when it comes to the overprints, that's down to like 25%. So much fewer of the overprints contain the titanium oxide whitener. Again, the significance of this is quite unknown, but clearly there appeared to be a difference in the paper or the proportions used for the overprint and the normal stamp. This is something that I still find hard to do, even on a cheap stamp, which is basically to destroy it by tearing a corner off and doing a fiber analysis on it. So we wanted to look at the paper fibers, the plant material that made up these stamps. And this is a routine method that's quite commonly done. It's quite easy to do at home. You tear off a bit of paper, you treat it, and you disintegrate it in a household blender. You put a drop on a microscope slide, you stain it and look at it under a microscope. And this is basically what you find. The plant materials used were esparto. Esparto is a grass that grows in North Africa and Southern Europe around the Mediterranean. It was used only really in the UK to produce quite high quality writing papers or book printing papers. It has quite good properties. It has less expansion than a paper not using esparto, and it gives the paper a nice finish for printing and produces a clearer, sharper image. These are the sort of sickle shaped fibers that you see throughout. And then you see cotton as well. This was used extensively in early papers. Papers were only made from cotton up until like 1860. And then you have these softwood tree fibers, spruce in this case, which are a common component, and a much longer fiber length. So the cotton and the spruce give the paper strength so it doesn't fall apart easily. And that was exactly the same for the barium only paper. That's in the next slide. That composition was the same for the barium only paper and the barium and titanium paper. So both made from the same raw materials, but when it came to adding a filler whitener to it, there was a difference in the treatment. So same raw materials, but slightly different processing. Actually, let me just go back to this slide. This is a real aside. So the spruce would have come from Sweden in the 1930s. In the UK, we didn't have our forestry plantations back then, and there wasn't a whole lot of spruce. So the spruce from Sweden, the esparto around the Mediterranean. I was looking at an early Canadian stamp from, I think, the 1860s, and it was made of all cotton. And by that time, the cotton would have come from the southern United States and produced basically in the slave trade. And I do have to say, I got quite spooked when I realized that this piece of stamp paper was actually supported and produced by a product of the slave trade. It kind of made history really come alive for me. Okay, I'm going to run through these fairly quickly. And I'm hoping that everybody here knows these techniques. The reflectance spectrometry, which measures the wavelengths of light, and this was done on the blue area, and it measures about 7 millimeters squared from the surface. And when we look at the selvage, for example, so not this area of blue ink shown on the left, but when we look at the white edge of the stamp, we just get this general reflection of white light with no clear patterns to it. When we look at the reflectance of the normal stamp, which is shown here in light blue. So that's the 1, 2, 5 lines, and the aniline stamp, which is the dark blue lines. We don't see a difference in the shape of the lines. There's a peak to the left at about 470 nanometers. And then there's another smaller peak reflectance in the slightly more yellow-green wavelengths. And these make up the color blue, but no difference in the reflectance from the normal and the aniline stamp. No obvious difference in those inks. If we look at the fluorescence emission spectra, again from the same point in the blue ink, and again we start off with a sort of baseline and we look at the selvage, we see that the paper always fluoresces, particularly strongly at about 500 nanometers. And then there's very little fluorescence, maybe a tiny peak at about 630, but no fluorescence, no fluorescence above that. So that's our baseline. And of course, when we do the reflectance for the blue ink, we also include the reflectance from the paper as well. When we look at the reflectance from the two different normal and aniline stamps, we have the normal stamp is the top graph, and we have the control line of the selvage in black and the blue pigment line in blue, and you kind of have to subtract the two. So the new peak is at this areas here, which is in really around the 700 nanometers, and the this one, which is 755. So yeah, so that's about 730 and about 750. Again, when we look at the normal stamp, the aniline stamp, and again at the acetone treated stamp, which mimics the aniline stamp, these reflectance patterns shown in the blue ink are all the same. They all have this peak around 700 nanometers and 755 nanometers. So again, there's absolutely no indication to show that the inks are any different between the normal and the aniline stamp. When we look at the elements in the X-ray fluorescence, we look at a much smaller area, but the X-ray fluorescence has penetration. So we actually look at the elements in the ink, paper, and the gum. So it shows the elements present. If we look at the black selvage area here, we see the baseline where we are getting not very much calcium. We're getting the barium, which was the filler in this one, not much cobalt, and no tungsten either. So going on to look at the inks in more detail. In the paper, I mentioned before, we have, it's the black line, potassium, calcium, barium, and sometimes titanium, which is shown here in this second plot. We get a titanium peaks coming in. Nitrogen and argon, the nitrogen on the left and the argon here at about 3 is from the air. And then we get outside sources of nickel and iron. The detail plots are just showing how you determine if titanium is present. The ratio varies of the 4 different peaks that barium gives, and you get a different signature showing you that titanium is present. The blue pigments are coming through at this end with cobalt and tungsten with energies of around 7, 8.5 and 9 point something. And this tells you that the blue ink could be either tungsten blue oxide, which contains tungsten, or cobalt blue, which contains cobalt and possibly aluminium. If we do the same thing comparing the normal and aniline blue ink, and the aniline ink is the dark blue here, they almost overlaid. So the aniline stamp is on the titanium and barium paper, but the signals from the blue ink are identical. So again, there's no evidence whatsoever to show that the ink used for the normal stamp differs from the ink used in the aniline stamp. Now, if we look at a different form of spectroscopy, the FTIR, which looks at compounds rather than elements, we can start to see some indication of what may have been used in the stamps in terms of compound. And this here is a plot of the paper, and we have the lower blue line here is an FTIR plot of cellulose, which is the major component of the paper. And then if we look at the plots from the selvage, the white part, we see they're almost identical with some slight difference at the kind of top end, the wavelengths or wave numbers less than 1,000. There may be an indication of some difference between the barium only lines, which is in black, and the barium and titanium lines, which is in red, but no idea of the significance of this. One thing to point out is that the FTIR method has very, very limited penetration. So even though it looks at a very small area, 1.5 millimeters squared, it only looks at the surface of the paper. When we look at the paper and the blue ink, and this is a plot that's a little bit difficult to describe here, we have 3 different standards for cellulose, the blue line, calcium carbonate, which was found in the blue ink, which is the red line. So if you remember from when we added hydrochloric acid, we got bubbles from the blue ink, but not from the paper. Here is a standard for calcium carbonate. The green line is for barium sulfate. And when you look at the signal from the normal only stamp, you see that there's calcium carbonate in it because the peaks on the red line match up with the peaks on the black line. You see there's cellulose in it because, again, the peaks from the cellulose, the blue line, match up with the black line. You don't find any obvious barium sulfate signal, even though that we're fairly certain barium sulfate was in the paper. And that's because of the total lack of penetration of the FTIR. That was the conclusion that we came to there. If we look at the normal and aniline stamps for the blue inks, and we just compare these 2 lines, we see some differences, but it's really difficult to interpret them. The blue bar are where the peaks for cellulose would occur. So everything left of the blue bar, the end of the blue bar, is a cellulose peak, and the peaks on the right. If you look at the red bars, I've messed it up. Start again. If you look at the red bars, that's a calcium carbonate. So we find that in the blue inked areas of both stamps. And if you look at the black circle, there's an unknown compound, but it's present in both the normal and the aniline stamp. So again, with the FTIR, there's no indication that the normal and aniline blue inks are different. So we set out to do various techniques to see if we could see a difference between the inks. And I was really expecting or hoping that we would find a difference somehow between the aniline variety ink and the normal ink. So these are the conclusions, really. With respect to whether the aniline stamp is a real variety. So is it a genuine variety? Should it be listed in the Scott and Stanley Gibbons catalogues as a proper stamp? Firstly, the aniline variety was discovered 50 years after printing. To me, that means it's very unlikely to be an original variety from 1939. So it's circumstantial evidence that it's something that was created well after printing from something. The other thing that I find extremely surprising is that the aniline stamp is equally rare in both the normal stamp issued in 1939 in April or June, and the overprints in the 2-cent and 4-cent surcharge that were overprinted, presumably from stock left over. I really cannot see how a batch of stamps printed in New Malden using a different ink suddenly appear in the same rare proportions in the normal and the 2 overprints. I just can't imagine that happening. No difference were found between the blue ink of the normal and aniline stamps. So it's very clear that these stamps were made from the same recipe, the same ink. However, there is a possibility, and this has happened in a Newfoundland stamp, that there's a poorly made batch of inks. So the ink wasn't properly prepared. It dissolved in the varnish like linseed oil, and it just seeped into the stamp when it was printing. So it could still be a genuine variety, and it could arise from a poorly made ink, but they're not different inks. The blue ink bleeding, darkening the red surcharge. I don't know the significance of that. It's clearly a chemical reaction that happened in the red ink. It happened in the acetone treated stamp, the artificial stamp. There's something in the blue ink that changes the chemistry of the red surcharge. And I say that because the blue bleeding is so faint that it wouldn't in itself cause such a darkening. The fact that the aniline effect can be so easily faked by acetone vapor means it doesn't prove that it's not a genuine stamp, but it does prove that the ink is rather prone to bleeding. This could easily happen by being stored in early plastic mounts, which weren't as inert as the more modern ones, or it could simply be faked by somebody who is trying to make profit out of a rarer variety. The 2 types of paper that I find incredibly interesting, but I don't think it's got anything to do with the aniline stamps, and I haven't analyzed enough of them. But certainly it's not impossible that the addition of titanium didn't stabilize it. But if it was the case, the aniline stamp would be in the proportions of the barium and titanium papers, which was around about 75-25. So the aniline stamp would be much more common. The fact that the blue ink contained an extender calcium carbonate, I don't think's relevant to whether it's a real variety or a fake. And I really leave it up to participants to draw their own conclusions as to whether I spent $200 and many other collectors spent a lot of money getting the aniline variety, when in fact it isn't really a real variety at all. Thank you for listening.
Thanks, Tony. That was pretty interesting. I've got Russ Sampson with his hand up. Russ.
Thanks again, Tony. Loved your talk. Have you measured the transparency of the paper between the aniline and the normal stamp? Because one obvious difference would be that you would see the ink more apparently from the backside if the paper was more transparent. And so just holding the two up to the light and seeing whether the selvage was letting more light through in the aniline one might be some evidence.
I should quickly rush out here now and get the two stamps and hold them up to the light. I haven't actually, I don't think I've measured paper thickness on that. It's a very, very real comment question. I haven't measured it. I really don't think it's important. I certainly haven't noticed it. If you you can't see these right now. If you look at the pictures of the aniline stamps, there's no obvious thinning of the paper, but it's a very good point that I should absolutely check on. So thank you very much for that.
Thank you.
Jill Morell, you're up.
Anthony, I wonder if similar work was ever done on another well-known aniline paper, Canada Chateau Ramsay, $1, about the same period.
I think that's one of the ones that Rich Judge has analysed, and there has been similar work, but I think perhaps Rich is probably the best person to answer that one and give his
He's here and ready, I think.
Yes, the Chateau Ramsay is a really clear case of a genuine aniline ink. The chemistry of the normal and the aniline ink, the spectra are all identical, and it's my contention when anybody looking at that particular issue is that it's just a poorly made pigment that was actually, the dye was poorly formed into a pigment, and it bleeds under certain conditions.
Thank you, Richard.
And in that stamp, Rich, you get used and unused examples of the bleed stamp, don't you?
That's right. And I also was able to correlate the percentage of bleeding through the paper versus the fluorescence signal of the stamp. Just an aside, Tony, I guess I'd like to emphasize that in the resolved fluorescence experiment, the peak at around, what was it, 750, way off into the red, that's a very good indication that it is the same ink because the peak has not shifted. Whereas in the case of the Newfoundland 8-cent, I think it's 8-cent, Prince George
yes.
issue, I'm trying to remember who's who. At any rate, that particular aniline ink, that is a separate ink, or at least a separate batch, because the fluorescence signal is shifted noticeably between the bleed through and the normal. So in that particular case, you can say that the aniline ink is a different ink, or that it is a different ink, and it was a bad ink to begin with. So the two stamps between Chateau Ramsay and the Newfoundland stamp, one is a definite same ink, one is a different ink that is bled.
Yeah, thank you.
Joe Bowling, you're up.
Yes, first off, when you had to tear the stamp corner off, couldn't you have done the same thing by just taking a few fibers from the edges of the perforations?
I I have tried that on stamps that I don't want to destroy. You can't really tell anything, and I've looked under various microscopic techniques. You can't really see anything unless the fibers are stained. You could certainly tear off a few and stain them up and look at them under a microscope and determine what they are. I just never really want to even do that to a rarer stamp. So you can almost do it. It wouldn't give you a very satisfactory answer. What you can also almost do is just look at the paper under a microscope at like ×100, and you can identify some of the fibers there. So if you have a known standard, like you've already torn off a corner and done a proper analysis on a stamp, I can look at the aniline stamp and see if it looks different, and it doesn't in that case. You can't see any obvious difference in the fibers, but again, I don't know what are the smallest fibers you could get away with. You want to be analyzing usually about 300 fibers to get a good frequency plot of the different components. But even if you did just 10 fibers, yeah, you could start to do that. I think, yeah, I think you're right. You could. It wouldn't be very satisfactory, but you could at a push.
Okay. On another topic, any kind of storage contamination that created any sort of oil, such as the obvious polyvinyl chloride storage media, is going to change the translucency of the paper, and also could very well cause that bleeding and the discoloration into the red with a reaction of the oil with the blue ink. So I think a storage contamination may be indicated here.
Can I ask a question back? You mentioned an oil in those PVC early protective mounts. Is it an oil, or is it a more volatile compound? Is it an oil that sinks into the paper? Do you know that, or because that's really interesting?
They deteriorate into several different compounds, one of which is hydrochloric acid. And it depends on, what exactly the composition of that PVC was, and that is very variable. But I've seen, old holders that were literally dripping with liquid something. I have many examples of PVC damaged paper money where the paper is obviously oily. I mean, you can feel it, you can see it when you hold it up to a light, and it also changes the colors of the inks.
That's really fascinating. What I was hoping to find was an impression of the stamp on the transparent PVC facing, because I imagined if you might get some I've forgotten the word now, some runoff of the image onto the PVC. Have you ever seen that in your banknotes?
Yes, I have examples of PVC pages where you can identify the note that was in that holder. If you put a piece of white paper behind it, it's quite clear that the ink is transferred into the PVC.
Oh, that's fantastic. I'd love to find that for this particular stamp, because I think that would seal its fate as a changeling. Yeah, thank you. That's really, really interesting.
Not as a non-scientific comment on it, it would occur to me, having been in the auction business and seen a lot of US collections that had the infamous crystal mount mounts, which did indeed degrade. I wondered if the anilines tended to be never hinged, and implying that they may have been in a mount as opposed to hinge stamps, which do not look like the anilines, which would have been just against paper in an album.
You know, that's a really good thought. I've never seen a hinged aniline stamp. All the ones I've seen for sale have been unhinged. In 1939, when did these PVC mounts occur? When were they made? I thought it was in the 50s, actually.
I certainly was using them in the 50s.
So why? Yeah, no, that's really, so they should have been hinged earlier than that. This is why I love these sorts of meetings, because discussions, because you get so many really good comments from people.
Yep. Bill Ullom, one of our presenters, offered a comment too, to say that the PVC degradation products include hydrochloric acid and fragments of the petroleum-based polymer backbone.
Excellent. I shall copy some of these down and think them for later. You might see with the hydrochloric acid a deterioration of the paper as well. I don't know if you could detect that in any way.
Well, the translucent is deterioration.
Yeah, that's right. There's a few things to look at.
I don't know if somebody like Vance Auctions gets in collections of crystal mounted stamps anymore, that you could look at them and say, oh, these all look like anilines.
I don't know. I've spoken to two dealers, Gary Lyons and John Jameson, when he was in business in both in Canada, and they immediately said with this aniline stamp that it's been kept in old plastic mounts, and it was very common with the blue pigment. So they've absolutely seen it. I'm not sure they've seen it for this particular stamp, but it's very well known to them. When I had some stamps expertised, not this particular one, but some other similar ones that look kind of similar, the Royal Expertizing Committee wouldn't certify them as genuine because they said they can be faked so easily, and they don't believe they're a variety. So I think this is a fairly well-known effect of this degradation by these early PVC mounts. What it's not is damp conditions, because, and I've seen that on earlier stamps, that damp conditions cause the ink to bleed, but it also affects the gum, and the gum on these aniline stamps is pristine, so it's not being stored in damp conditions to make the ink run.
Very good. We have answered all the questions in the queue. Nobody has their hand up. So let's take a 10-minute break. We will reconvene at 1:15 with our next presenter. Tony, thank you very much. And thanks to all of you again who asked questions and contributed to the discussion afterwards. We'll be back in a few minutes.
Yeah,
All right, let's start again. It's 1:15 Eastern Time. The first thing I want to do is add a comment that Joe Bowling sent just a couple minutes ago. He mentions that the PVC take-up of ink from a note that I described before happened before there was any visible change in the paper. The paper looked and felt perfectly normal, but the ink image in the plastic was very plain, and I would say that matches my experience with those plastic mounts as well. Let's turn to our next topic here with Majid Hosseini, who is our presenter. He is a mathematician who specializes in probability theory. Over the last decade, he's been designing and building machine learning systems at technology companies in the San Francisco Bay Area. His primary philatelic interest is the U.S. 1851 and 1861 series, two 1861 series. He has studied and collected various aspects of this issue, including plating and postmarks. He's currently studying the usage of this issue in California, particularly in the Bay Area. He also has a keen interest in Iran's 1911 to 21 issue and its postal history, which we're about to learn more about. Go ahead, Majid.
Well, thank you very much. Let me first share my screen. So what I would like to talk about is this issue, very well known practically in every worldwide collection. You can see examples of this stamp. It's very common. It's the most well-known example of the Qajar period in Iran history. And it was printed in 1911 by John Enschede and Sons of Netherlands. It was issued for about 10 years. There were many, many prints of this series. And there was later on one more reprint of this series issued for collectors in Europe because of high demand. And this is, they are pretty clear how they are based on their gums. This is most mint examples that you see actually in worldwide collections are the reprints, but the used ones are mostly originals. And the early prints of this issue were done using the wet printing method, and the later prints were done using dry printing method. And I believe in that period, a lot of places were experimenting with using wet printing and dry printing methods. As far as I know, for instance, the Bureau of Engraving and Printing, which was printing actually Washington Franklin's at that time, was also experimenting with similar things. That's why we have the 2mm spacing and 3mm spacing in Washington Franklin's. So, and whatever I'm talking about actually today can be applied to the same stamps also in Washington Franklin's. I mean, my goal more than anything else is to introduce just the technique more than the results, though the results are also, I think, interesting. So the vignette for this stamp was recessed, and the frames were typographed. Because of the shrinkage, the wet print stamps, actually the vignette height, as you can see here, is shorter. I've put two of them side by side, and you can see the vignette height is actually shorter for the wet print stamps than the dry print stamps. The standard catalogs like Scott or Persifila, which is the specialized catalog for Iran, identify the dry print variety with 23mm vignette height, and the wet print variety with 22.5mm vignette height. But I was sort of not buying that number. To me, it seemed like there has to be some variation. This can't be just so strict. We are talking about physics and chemistry, right? The paper shrinking, it cannot be all exactly the same thing. So I started basically collecting a large number of these stamps and measuring them. I scanned them at 1200 dpi, and I started basically measuring them with better accuracy. And And I started seeing basically variation in the data. This is a histogram that I started collecting basically, and you can see that there is indeed variation in the vignette heights. I talked to one of the experts and I said, okay, how do we know that there aren't any another name, by the way, that is used for these is tall portrait and short portrait variety. So I asked one of the experts, how do we know that there aren't any wet prints that are tall portrait? In the sense that how do we know that there aren't any dry prints that are short portrait? In other words, how do we know that there isn't any overlap between these two, you know? And he said, in his opinion, anything with a vignette height of 23 millimeters and higher, he considers it as tall portrait. Anything below 23 millimeters, he considers it as short portrait or a wet print variety. So I'm going to use these interchangeably: wet print, short portrait, tall print, and tall vignette, and dry print. So I started thinking, okay, how can we basically come up with a mathematical model for this? To me, you look at this histogram, 23 millimeters is not really bad as a cutoff point, but when you actually look at the data, there is a lot more resolution, and you can see the numbers get pretty close to each other. So it's not clear to me that there is really a hard boundary between these two issues. So the thinking came to me that maybe a better approach is a probabilistic approach, and we can basically think of these two as two normal distributions, one per variety. And can we estimate the means and standard deviations of these two distributions? Well, one option would be to say, okay, the 23 millimeters is the cutoff. Let's take anything above 23 millimeters as tall portrait and anything below as the wet print or short portrait, and calculate the means and standard deviations of these two varieties, these two distributions. But that would be a circuitous solution, right? Because it would already assume the answer, the 23 millimeters, as a hard boundary, and then use it to come up with these soft boundaries for these two distributions. So a correct solution shouldn't make such assumptions about the location of the data. So that wouldn't really work. But instead, we can use actually a technique very common in machine learning world called the expectation maximization algorithm. The original algorithm came out in 1970s, but the proof of the convergence actually had a flaw in it. And it took about 10 years to come up with actually a correct solution for the convergence of this algorithm. But now we have a correct algorithm, and it's very common to use. The assumptions we are going to make are actually pretty simple. We are not going to make very complicated assumptions. The only population-wise assumption I'm going to make is that there is a probability pi. There's a number called pi that basically describes the proportion of the dry print varieties in our population. And because there are only two varieties, it's just 1 minus p is going to be the proportion of wet prints. The other assumption I'm going to make is that the distribution of the wet prints is described by one normal distribution with some mean and variance, and the dry prints is going to be with another normal distribution, with another set of parameters. I am not going to make any assumptions about the actual values of these. But what I'm going to do is to use the EM algorithm, the expectation maximization algorithm, to come up with the estimates for these parameters of these models. So all I know as of now is that basically I have a blob of data, and I'm just going to assume that there is some number pi, and there are two normal distributions that describe basically the spread of this data, and I'm going to find those purely mathematically. So let's just for a second assume that we actually know the varieties of each stamps that we have in our sample. Okay, if we knew that, then that would make the problem extremely easy, right? We would just pile them into different groups And for the wet print type, we would just calculate the mean and standard deviation. And for the dry print, we would calculate the mean and standard deviation. And that would just give us whatever parameters for the normal distributions we wanted. And the proportion of the wet prints or the dry prints in our sample would be our estimate of the pi. Okay. So in other words, let's just say we have like an indicator random variable delta that is 1 if a given stamp is dry print variety and 0 if it is wet print variety. If we know the type of the stamp, then we know its associated delta. And if I just rewrite basically what I just told you, as far as, okay, putting them everything in separate piles, these would be basically our estimates, okay? For instance, if you look at pi, remember, delta becomes 1 every time you have a dry print variety. So the sum of these deltas for all the stamps in our sample is just going to be the number of dry print varieties. And this whole number is going to be the proportion of dry print varieties in our sample. And similarly, let's look at mu0, for instance, mu0 hat. So remember, delta is equal to 1 every time you have a dry print and 0 every time you have a wet print variety. So the sum in the numerator is just going to be the sum of the vignette heights in the wet print varieties, because in the dry prints, it is going to be 0. So this is just the numerator is the sum of the vignette heights for the wet print varieties divided by the total number of the wet print varieties. That would be average, basically, the sample mean vignette height for the wet prints. So if we knew all of these, if we just knew these deltas, then we were done. But the problem is we don't know the values of these deltas, right? But you're going to basically do a trick here, a mathematical trick, which is that we're going to replace deltas that we have here by the expected value of the deltas, by the average value of these deltas. Given that, now here is where the trick and the convergence questions come up. So we will, let's assume for a second that we know the parameters of the model. But even if we don't, we know we can estimate them. Let's suppose we have some estimate of the parameters. Okay, then we are going to replace basically the deltas that we had with their average or expected value. But because deltas are just basically indicator variables, their average is just the probability that it is equal to 1. The average of an indicator variable is just the probability that is equal to 1, given that we know the parameters, or we have some estimate of the parameters. Now, if we replace basically everywhere we saw delta with our estimate for our mean, basically, we're going to get these equations. Something I should mention is that when it came to these sigmas, I actually put a lot of typos here. There aren't any squares in the paper. And I think I missed, actually, I didn't match the numbers for the mu's and sigmas correctly here. So that's something just to pay attention to. But so this is what we get if we actually replace every delta with our estimate with this for its expectation. Okay. But like I said, we don't know the value of these expectations either. Okay. But we can actually make an estimate knowing a few things. We basically can use a Bayesian argument to basically say, okay, we had two normal distributions, so we know how the density of a normal distribution looks like. And we know that we have basically a mixture of these two normal distributions, a weighted sum of these two normal distributions. Based on that, if you actually do the math a little bit, you're going to get this estimate for the gammas, okay, which depend also on mu's and our sigmas that I mentioned before, okay. So this is called the responsibility of basically these are called the responsibilities. And as I said, they're just basically described in terms of the parameters of the model as of the point that we have estimated, okay. So this also, like I said, it looks like a circuitous argument that we want basically the parameters of the model in order to estimate the gammas, but then we use the gammas to estimate the parameters of the model. This kind of looks like a circuitous argument. But in reality, the algorithm is iterative, and we are doing a convergence argument. So we start with some initial values for these model parameters. And we don't really have to look very hard to find reasonable initial estimates. For pi, we're just going to pick 1/2. Like, we are going to assume 50-50, the model basically gives us wet print or dry print. And for the means of these two normal distributions, we're just going to pick basically the mean of the entire sample. And for the standard deviations, we're just going to pick the standard deviation of the entire sample. So these are not complex, basically, estimations for the initial values. But once we have that, we immediately get an estimate for gamma as initial step. With that estimate for gamma, we can make another set of estimates for the model parameters. Using these model parameters estimates that we got, we get a new estimate for gamma. And then we can just iterate this continuously until we get a convergence. And this actually converges pretty fast. In our example, we are going to get basically the following for our estimates for models. So the proportion of the dry print varieties is about 83%. And this actually conforms with what we know empirically, that dry print varieties are more common, wet print varieties or short portraits are scarce and much more expensive. Also, the 22.5 that we had for the vignette height of the wet print varieties, we really get 22.61 millimeters for the vignette height of the wet print varieties. And for the vignette height of the dry prints, we get 23.19. Something else that I think is interesting is that, and it kind of makes a lot of sense, at least to me, is that the variation in the wet print varieties is twice as much as the variation in the wet print varieties, 0.13, is about twice as much as the variation in the dry print varieties. So that's also, I think, an interesting observation. So now we can actually look at our expertizing questions, things that are related to the application of the STEM, now that we have a model, okay? So the first question that I think is the most important question is that for what vignette height, we are going to get equally likely for a stamp to be of the dry print variety or wet print variety. So let's say that if you pick a random stamp, the vignette height is X, okay? So remember, the indicator for dry print or wet print is delta. So we are asking to find the X. We are looking, basically trying to solve an equation. We want to find the X for which the probability that delta is equal to 1, given that the vignette height is equal to X, is the same as the probability that delta is equal to 0, given that the vignette height is equal to X, right? But remember, according to our model, we describe the probability that delta is equal to 1, which is that exactly what we call gamma hat. We know exactly what the formula it is for it, right? And because we have the model parameters, we can actually write this down, which is only basically something in terms of X, right? Also, so this describes for us the left side of this equation. But the right side of this equation, remember, P of delta equal to 0 is equal to 1 minus P of delta equal to 1, right? This is P of delta equal to 1, okay? The P of delta equal to 0 is going to be 1 minus this quantity. If you take a look at this quickly, you will see that it is just going to be 1 minus pi 0 divided by this same denominator, right? So the two sides of this equation are going to have the same denominator. The numerators are just going to be pi times phi 1, and the right side is going to be 1 minus pi times phi 0. Now, again, these are all describable in terms of our model parameters and a normal distribution density. So we can just solve this for X. And if you do solve this for x, you're going to get x is equal to 22.958. So that means for this value, the stamp is going to be exactly equally likely to be dry print or wet print. So you go any higher, you're going to get a dry print variety. You go any lower, you're going to get a wet print variety. So 23 millimeters cutoff is not a bad estimate, and it's reasonable, basically. So the question now, the next question is, assume we have a 23 millimeter vignette height. What is the probability that the stamp is actually of the dry print variety? So we are interested in calculating the probability that delta is equal to 1, given that x is equal to 23. Let's plug in x equal to 23 in our model. We are going to get basically 0.9385, which is about 94%. So per this model, if we declare any stamp with a vignette height of 23 millimeters of the dry print variety, we are correct in about 94% of cases. That means in 6% of cases, we are actually incorrect. So if we are really getting exactly 23 millimeters or somewhere even lower, we have to really be careful about our opinion to look for more fine-grained analysis and look at the image, for instance, the sharpness of the image to see whether it is genuinely of the dry print or the wet print. Otherwise, we can be making a mistake. So where can we get a little bit more confidence? These are normal distributions, right? So the tails drop off exponentially fast. And for a vignette height of 23.1 millimeter, this probability increases to 99.97%. So this might be actually a better threshold for declaring this stamp with high confidence to be of the dry print variety. So this is sort of the meat of what I wanted to say, but I kind of want to make some conclusions about what we just did. First of all, the conclusions I made required absolutely no subject matter expertise about stamps. And even my model required a very modest knowledge about the subject. There are two varieties, which are basically about the vignette. That's all I needed. I didn't really need very accurate and deep knowledge about the printing or anything like that. I didn't need to know image quality or how to distinguish a wet print from a dry print by looking at them or anything like that. But we use the data-driven approach, basically, to derive results that confirmed and refined the currently accepted numbers. And in addition, it allowed us basically to come up with an estimate of the certainty that we have in our opinion. Like I said, if we look at 23 as the cutoff, we are correcting about 93%, 94%. So we have an estimate of the certainty that we have in our declaration. And these are qualities that are very common across all machine learning models. And this is the reason they have had such an enormous success over the last decade. I mean, you have heard about large language models like ChatGPT. They know nothing about the language. I mean, it's called the large language model, but it doesn't know anything about the language. They just output the most likely next token in the text based on the training data they have been basically fed onto. So, and I think Philately and Postal history also could benefit from this advancement in the technology. And there are two really components to this advancement. One was the open source software movement that started about 10 years ago, 10, 12 years ago. A lot of very high quality software became openly available. Usually it's either in R or Python. These are the two programming languages that it became available. And it was developed by very highly competent software developers in large companies because everybody saw that there is a lot of benefit basically in doing this. And they also made a lot of data available. Large data sets became available. And I think this is the component that is missing right now in Philately. We have this open software available for free, but we do need large quantities of data. And I think large philatelic institutions such as APS, such as National Postal Museum or Philatelic Foundation, they can provide significant help by making available to the public the data they collect. And for instance, APS and Philatelic Foundation, I'm sure they scan every stamp they get to. So if they make these scans in high quality, high resolution available, I think that would be a significant help. Now, there needs to be probably some standardization so that the scan from Philatelic Foundation over time is consistent, and it is consistent with what comes out of APS. But especially I think for things like color, these could be very important, like the examples Jan Hafenmeyer mentioned last week. But generally, I think if this happens, we can have a major way for research that hasn't been, I believe, explored much yet. And I just wanted to basically show an example. Thank you. I'll take any questions.
I have some for you.
Please.
Let me see where I should start here. Let me get Paul Davey on here. I need to let him speak. Where'd he go? Paul. Okay, Paul, you're on.
Okay, thank you. Thanks very much for an interesting talk. I must admit to not quite following all the statistics, but you know, you've done it all for us. My comment was that in China, there's a similar issue with size of stamps being slightly tall and slightly short from the first Sun Yat-sen or the second Sun Yat-sen issue of China, which is always put down to the grain of the paper that it was printed on, whether it shrank vertically, if you like, or shrank horizontally. Do you find there's a difference in width of the vignettes as well?
You know, I've heard of it. I haven't checked. I've heard that there is a difference, but because most of the conversation is actually about the heights, I never bothered to check. But I think there's something to that.
I'll be prepared to go out on a limb and suggest that the tall stamps will be narrow and the shorter stamps will be wide. So that may give you another variable to help the veracity of the model.
Correct.
Thanks.
You're welcome.
Thanks, Paul. Gary.
Okay. Couple of observations. What first caught my attention was when you came up with an analytically determined 22.958 versus 23 from the experts, or your expert, I guess, singular. I think that just speaks so highly about the value of experience among expertisers to come in with that kind of closeness. But for the wet print, I don't have any scientific basis for this observation, but I am skeptical about whether the assumption of a normal distribution, meaning that it's symmetrical and not skewed, implies anything. Is there some? How sensitive is your methodology to the assumption of perfectly symmetrical or reasonably symmetrical bell curve? Might the greater standard deviation of the wet print be a clue?
You know, there could be some fat tail, for instance, over there that you need to model it with, for instance, a T distribution or something like that. Instead of a mixture of Gaussians, you could potentially do it with the mixture of T distributions. But considering that the results came out almost identical to what came out of the expert's opinion, that kind of alleviated that concern for me, that there isn't any fat tails. And actually, if you also look at the data, let me go back and share my screen. if you look at the data, you don't really see any signs of heavy tails. I didn't really go back and check using the log diagrams and so forth, the tails, but just eyeballing basically I'm a big advocate and fan of eyeballing everything. And if you eyeball just these densities, you don't really see a fat distribution over there, you know. So the tails seem to fall off after a certain point. You don't see much going on over there. It is possible, but like I said, considering that everything just matched what was the experts' opinions and the accepted wisdom, I kind of assume that that's probably not what is happening.
I suppose my concern has to do with the quality, specifically the irregularity of paper production during that period of time, and whether shrinkage might have been somewhat or perhaps highly variable in a wet print process. But again, I'm intuiting this. I've got no evidence at all.
Right. I mean, like I said, at least in the sample that I had, I think a normal distribution kind of looked reasonable. And I don't think the variability so much would change the nature of the distribution as much as the fat tails. The fat tails mean basically that you would be very likely to see very tall portraits in wet prints. And that just doesn't show itself that much.
I've got a final comment on your recommendation that folks like the PF and the APS and so forth provide the scans as a data sample. I do know that at APS, we were scanning only for purposes of producing an image to embed into the certificate. So we were doing 300 DPI scans. I had proposed, nothing ever came of it, I had proposed that we build a system which would distribute images before the mail arrived to the expert, and they could start the analytical expertizing process from images. Obviously, having the stamp is critical to issuing a certificate, at least in my view. But I thought we could accelerate the workflow, and that would have required 600 or 1200 DPI. I'm not aware of whether any of the other organizations that expertise do it any differently, but for us, at least at the moment, it's only a 300 DPI, and I don't know how much value that would be for what you're proposing.
Right. I don't know. I don't think it will be very valuable. I think high resolution, high quality images would be much more useful. But that was just one side of basically what I was proposing. We see that I am pretty sure the National Postal Museum makes a lot of measurements using XRDs or VSCs or other things. These are all basically quantitative data coming out. And I think making those available to the public would be enormously useful in the long run when there are enough data accumulated that you can do something. Like example Jan Hofmeier showed last week as far as clustering different colors of the 1961 series. That requires a lot of data, you know, to cluster basically all those colors in various, you know, components. That requires at least several hundred, depending on how many clusters we are looking at, and maybe more. So I think the more data becomes available in everything and anything, you will find somebody creative to do something with, you know, and there are very, very creative people out there.
Thank you, Majid.
You're welcome.
All right. Joe, you've got a couple of comments here.
Right. First off, what do you have that you can carry around at a stamp show that has the accuracy of 1/10 millimeter measurement? Is there a loop that has a reticle in it that can actually cover the entire stamp and measure something 23 millimeters long?
I think if you want to take it to stamp show, just eyeballing with a millimeter size just measurement, you should be able to distinguish the tall versus short if you are just going by the 23 cutoff, not something like what I was just describing. It's kind of visible. And when I get lazy and I don't want to really scan things, I just put it on my millimeter, basically ruler, and I just measure it. If it is less than 23, I just go with it, even though that's really not what I should be doing. But no, I don't think there is a loop that is that accurate. You need a scanner.
I can measure to a third of a millimeter eyeball, but anything closer than that is really guessing.
Yeah, absolutely. Absolutely.
All right. The damp, calling wet printing versus dry printing. Wet printing is not really wet, it's just dampened. And the degree of dampening is probably also going to have an effect on the degree of shrinkage. So
exactly.
That's a variable.
Exactly. But that's why the wet print has more variety, more variation, right?
I would assume so, yeah.
Right. And
deviation.
Right. And as far as I know, at least in the Bureau of Engraving, if I remember correctly, even the dry prints the paper is dampened. If I remember, the dry print, I think is 20% moisture, and the wet print is 40% moisture. I could be wrong, but these are sort of the numbers I'm remembering vaguely. So even the dry print, they basically moisten the paper.
Well, I'm not aware of any moistening of the dry print paper. Maybe at the very beginning, but the whole object of going to a dry print press was to avoid the labor and the drying time necessary between printings for the dampening.
Could be. I'm not a printing expert. I'm a machine learning expert. And this is what I remember reading somewhere. You might be right, though. You could be right.
Thank you.
All right. Russ.
Majid, very interesting presentation. Shows a lot of interesting potential. I have one question. Did you dimensionally calibrate your scanner? So find out.
I did.
And so the corrections were applied to your measurements.
Yeah, I mean, I basically scanned the same ruler vertically and horizontally to make sure that basically, and I compared them, they were exact match. The scanner was brand new. Epson 600 something, I don't remember. But it's in the paper. But it was a brand new scanner. I actually calibrated it. I measured basically the same thing, both vertical and horizontal, to make sure that they match together. And they did. So it should be fine.
All right. Thank you.
You're welcome.
Okay. Alan.
Yes, thank you. I think actually the previous answers there were sort of honing in on my question there about the accuracy of the measurements and the error bars on it. I guess you were doing this from 1200 DPI scans and
1200 DPI, yeah.
1200 DPI, so a pixel count essentially of between the two limits, and then it's 1/1200th of an inch.
Exactly.
Okay. Thank you.
Welcome.
All right. I have no more questions in the queue. So what I would propose is let's take a 6-minute break and we'll start Mr. Ullom's presentation at 2:00 Eastern time, 6 minutes from now. And Tony.
I just turned on my microphone to say hi. I have a question.
Yes.
Incredibly interesting talk. And I love your analysis, which I kind of followed most of, as opposed to all this XRF stuff, which I struggle with. The typical philosophy is that wet prints are on flat plates, and we move to dry printing on curved plates. although there's both overlap in those. You could get dry printing to flat plates, and you could get wet printing to curved plates. And then the other thing attached to that is that if you measure in both the X and Y directions, you get more information. Do you think you could do your analyses in 2 dimensions to account for both the height and the width to see whether...
I mean, it is applicable for sure. We can look at the 2-dimensional normal distributions, right? 2D Gaussians, basically. Or like Gary mentioned, you could even look at 2-dimensional T distributions, right? I mean, so there is no question we can do that. I am not sure as far as what we wanted to accomplish. It will tell us a lot more as far as the spread of the dry print versus wet prints, but it's certainly doable. Absolutely. Yes. You can do basically a Gaussian mixture model in any number of components and any number of dimensions that you want. But the more dimensions you add, the more components you add, there is a chance that you're overfitting the data.
I had another question come in from Louis Morel. Go ahead.
Thank you. Majid, I have 2 questions, and the first one has been partially answered by other members in the group, and maybe some participant can help out here. It has to do with the election by the Dutch company to switch from the wet method to the dry method. And I understand wet means moistened, dampened, not drenched or soaked. So can someone help me out understand better why they would have elected to do that? Why would they switch? Now, I think it was Joe who mentioned something about a different type of plate, flat versus curved. Maybe they changed their hardware. Is that possible?
So as far as the Bureau of Engraving and Printing, I don't think there is any rotary press version of this stamp. Okay. As far as I know, this was all flat plate prints. It was basically a plate of 50 stamps, and the same plate was used, as far as I know, for all the different denominations. So as far as I know, this stamp was entirely done using flat plate printing. The Bureau of Engraving and Printing switched at some point from flat plates to rotary press. But as far as I know, again, the 2mm spacing versus 3mm spacing and the moistening of those things, stuff that happened, they happened in the early prints way before the switch happened to the rotary press. So I don't think this distinction is because of the switch from the flat plate to rotary press. It certainly is not in this particular case, as far as I know.
Okay, so we're not quite sure why the Dutch then went to the dry print process. It wasn't.
No, they did. They absolutely did go to the dry print, but I don't think it was a rotary press print.
I understand that.
Certainly a flat print.
Yeah, right. So it was for some other reason that they switched. Okay.
Right.
The second question has to do with the cutoff point. You showed that there's approximately a 6% probability at the 23mm cutoff point that it could be one method or the other. So my question to you and to the other participants is, what other characteristics of those stamps that are near the cutoff point could we look for to determine whether it was dry print or if it was wet print? Or is there no way of knowing?
There is knowing. I am not the expert on that, but as far as I believe, and I've read about it, is that the wet print varieties, the image is kind of not as sharp as the dry print varieties. So somebody who is very good at that can distinguish between the two. I'm not particularly good at that, but an expert, I'm sure, can distinguish between the two. But
thank you.
The 20, that actually was part of my sort of reasoning, that 23mm I don't think is particularly good because there is a 6% chance that we get it right. We get it wrong. I think 23.1mm is probably a better place to put as a cutoff.
Understood. Thank you.
You're welcome.
I pulled out my Scott Specialized catalog for the stamps of the United States, and they have a note just before the Liberty issue, the 1954 stamps that for me were the ones I first remembered as a kid. And it says in 1953, the BEP began experiments in dry paper, moisture content 5 to 10%. In previous wet printings, the paper had a moisture content of 15 to 35%. So to stop reading from Scott for a minute, we know that they were using rotary presses long before that. They started that in the 1900s or 1910s when they were printing the Washington Franklin stamps. To go on from Scott, the new process required a thicker, stiffer paper, special types of inks, and greater pressure to force the paper into the recessed plates. The dry printings show whiter paper, a higher sheen on the surface, feel thicker and stiffer, and the designs stand out more clearly than on the wet printings. And for anybody who's collected the Liberty issue, it's pretty plain, especially the 8-cent Statue of Liberty, the bicolor, where you can see the variations in the red and the blue inks and how sharp the images look. So there it goes on to talk about differences in specific stamps here in the Liberty issue, but that's the basics of the wet versus dry printing, and it's not connected with flat versus rotary press.
Right.
I suppose it's possible, although we don't know for sure, that the paper on the wet printing, what did it say? The dry printing required thicker, stiffer paper. We might be able to see a difference there too.
Right.
Okay. Well, again, our question and answers have slowed down. So let's take a break. And it's now, what, 2 minutes past 2 o'clock. At this point, let's wait until 2:15, Bill, to start your presentation. And we'll go on as originally scheduled. Everybody gets about a 10 or 12-minute break here. And we'll be back at 2:15, ready for the final paper.
See you at 2:15.
Yes, thank you, Majid.
Thank you.
State that. If there is forensic work done, a certificate might cost more, and it might be worthwhile for some. I mean, there's obviously some material that would justify an increased cost. For some stamps that have catalog values of four figures or market values of 4 or 5 figures or more, the difference between a certificate that costs $50 and one that costs $500 is not material. And so, if that were the case, that certificate adds that much value to the stamp, it's worth more.
I think that's a valid point. I also like I share your concern about the inconsistency across expertisers, the lack of a consistent methodology, and I think the approach that we used during my time at the APS was to have, as often as practical, more than one expert look at a stamp. And it wasn't by vote. If we had 2 or 3 experts and one did not agree with the other 2 opinions, I would let them fight it out, if you will, rather than say, well, 2 out of 3, we're going to give it a cert in whatever direction it was going to go. It was not a consensus approach, but I think what it did achieve, and under my time there, the percentage of no opinions went up because of that conservative philosophy of mine. But I think that if multiple expertisers come to the same conclusion, even though they're not using consistent methodologies, they don't even have consistent reference collections. They don't have consistent experience. They come at it from different directions. But at least with 2 or 3 expertisers in the process, you've got something that might approach and this is not a mathematical use of the term, but a normalized approach to reaching a conclusion. On the other hand, what all of the expertising organizations issue are still called opinions, not facts.
Gary, that's true. And certainly the jury approach is what I had sought the first time the stamp was submitted for third-party review. And there was some bias there. I don't want to go any farther in it, but it was what it was. There was a jury approach the second time, but even the jury approach, in the absence of forensic analysis, came up with an opinion based on one data set. And I know in my world, in geology and in geochemistry and petroleum engineering and so forth, if you have one data set and that's all you have, you're going to come up with an answer based on that data set. You change the data set, you're going to get a different answer. So that's what we're facing, I think, in this case.
Well, thank you for a very important view of the expertising process. We've got a long way to go to get better.
Well, I don't want to pose a problem and not offer solutions. And so, that solution, Gary, as you were talking about, if we indicate on the certificate just what was done, was it a single person? Was it a committee? Was it comparative visual analysis? If there was forensic analysis, what was used? And have some discussion of the basis for the opinion, that would relieve, I believe, many collectors. I've had this discussion with collectors in a number of stamp clubs, a number of organizations, to where how frustrated they are that there's just nothing available for them, and the examiner's notes aren't always available, and the examiner's notes aren't always complete. And so if the certificate says, this is our opinion, and this is why, then I think that it was, and this was the data set we used, I think that would alleviate a lot of that problem.
All right, I have more coming up. Frankie, you are next.
Great talk, Bill. I had a question on what you considered good protocols for authentication. So would it be using like a single analytical method? Would it be using multiple analytical methods? Like what would you consider the difference? Because even within that, if you just use one instrument, that could tell a different story than if you used multiple, et cetera, et cetera.
Absolutely. Frankie, the more data we have, the better the opinion. That's my view of it. All right. That if we have a very small population of data, that the opinion resulting from that small population is not as supportable as one with a larger population of data. And again, if the certificate plainly states, this is what we did, and this is, even it could say for all available methods, this is what we did not do. And it could be a series of checkboxes, to standardize this, to come up with a standardized protocol across expertization. If you flip the certificate over and on the back, these are the checkboxes. This is what we did. This is what we didn't do. It's a possible solution to that. And at least it gives a value to the certificate, not in dollars, but in terms of how reliable is the opinion with respect to all the data that could be out there and researhed.
It does seem odd to me that you don't get like an analytical report of some sort with like an executive summary findings XYZ, that it's just a yes or no. It doesn't seem like the best for.
I agree. Absolutely. I completely agree. There are professions out there, in philately, expertization really isn't a profession for most expertisers. It is for some. Anyone can hang out a shingle and claim to be an expert, take out some advertisements in some philatelic journals, and start to run a business. But in the medical world, when a doctor has an opinion, the opinion is based on a medical protocol that is followed. And so, to me, that seemed to be a reasonable approach for how to deal with this.
Could future steps with this work be potentially coming up with a visual assessment protocol, and talking to different expertisers about terms that they often use, and then from there branching out into maybe different analytical methods? I know that's a huge research question, but the idea of like a consistent protocol seems like it could be useful.
Well, this is like looking down an anthill. You start going down, you look down one hole, and then all of a sudden you're going down 65, and then you're going down 165. And so I agree that it would be better to have some description of what was done and what was done and all of that. Frankie, the points you're making, your questions you have, very valid, and it leads to possibly some discussion between organizations as to what really are you doing, what are we doing, so that there possibly could be some standardization coming out of it in the future.
Thank you so much, Bill.
Thank you, Frankie.
Thanks, Frankie. Yanni, you've had your hand up.
Yeah, thanks, Bill. I'm really pleased that this is where we're ending up. My particular area was to try to get to grips with the color of my stamp, for similar reasons as you have with cancellation. I'm dealing with a case now where a very interesting incorrect use of a currency has been found on an envelope. The judgment has been from the 1860s. The judgment's already been rendered that it's fake. It was kind of applied afterwards, but forensic analysis indicates that it wasn't. That everything else is, about the gum and that on the envelope is genuine and dates to the time. And one of the problems I think you facing is that a judgment had already been rendered and they didn't want to contradict the previous judgment. In spite of the evidence, I have really just two. First of all, I think it has to be done. So the cost thing can quite easily be solved by looking at the cost. If you've got something that isn't that expensive, then it doesn't warrant that kind of level of forensic analysis.
Right.
But why don't we do what people do in every other sphere? All the auctioneers, when it comes to paintings or ceramics or whatever it might be, these days, before Spink or Sotheby's or any of these auction houses put anything up, they submit them to tests, forensic tests, to establish whether they are authentic or not. And those tests are justified because of the value of the items. So there's a very simple rule that we could apply, which is that if it's expensive enough to warrant forensic analysis, it should be forensically analyzed. Then secondly, we're not dealing with issues that are different from what other the issues that are raised by other collectibles. So, but the other collectibles are far ahead of us when it comes to authentication. So we don't actually have to learn that much. The learning has already been done. Museums, the same thing. They're far ahead of us when it comes to authenticating the things that they buy for their collections. So the learning is there. So we don't need to launch a massive experimental effort to develop the protocols. We just have to go and find out what the others are doing and adopt those protocols. So I think it's a fundamental problem in philately. Expertization has sort of evolved from a gentleman's, I'll use man rather than gentle person, sport, because it was men who did it, and who had a reputation that just made it impossible to challenge that. I don't think we should accept that anymore. I really think we should become more professional. The learning is out there. It should be done. It's very easy to relate it to the value of the item that you're looking at. And then that then actually leaves me with my question. What are we going to do about it? Because if we just talk about it, absolutely nothing is going to happen. There has to be some call for action or organized activity. Otherwise, we will just continue to have these discussions until we die.
I think one way, Jan, to do that is that those of us who are most greatly concerned about this issue can talk amongst ourselves and say, all right, this person of our group is the leader, and this is what we're going to do. And the person can start making phone calls and making arrangements for meetings. And the goal then would be to have a certificate with not just the emblem of the RPS or the BPP or APS or whatever it is, but they have an emblem on there that establishes that this opinion is based upon the protocol.
Yeah.
So
I would have
that
thought something like, I would have thought something like FIP ought to be doing something like this. So,
yeah.
And if you took the Philatelic Foundation, the APS, the Royal of London, and there has to be some equivalent in Asia as well, you would have enough established authority to establish protocols that then, as you suggest, it's not an organization-based protocol, but it's a sort of international set of standards. Anyway, that's my piece.
Jan, that's exactly right. On my last slide, there was a cluster of logos for some philatelic organizations. The reason that all the logos weren't on there is I couldn't fit them all in.
Yeah.
The point is that all of these organizations should have a seat at the table and offer their opinions. And as you say, some of these organizations, we may have some of the museums come in as well, and organizations that have nothing to do with philately, but they have all to do with expertization.
Yeah. Thanks very much, Ken, and thanks very much, Paul.
You're welcome. Archie, you've got your hand up. Do you suppose we can hear you this time?
I hope so.
Yes, we can.
Yeah. So first of all, I thank you very much. I agree with most of what you said, and I don't want to change the subject, but in the last presentation, somebody asked about a measuring device that you could measure down to the millimeters at a stamp show. I have a fine scale desk model magnifying comparator. that I carry around with me. I don't use it very often, but it's got 8 different reticles on it, and it's adjustable focus. And I don't think it was all that expensive. I'm a collector of China, and I use it on the overprints quite often. But it's manageable, and it would be handy if somebody wants to get between 23 and 22. Excuse me. It measures to the 1/4 of a millimeter, but it's got a maximum field division, needless to say. So that's just what I wanted to add. But thank you again, Mr. Odom.
Thanks, Archie. I've got some from our participants again, too. So Ted Nixon, you're up.
Thanks, Ken, very much. I guess I'm finding some of these comments quite interesting about having this protocol. As someone who has been involved on expertizing for well over 20 years continuously, and it is now a weekly job, I wish I heard from one of you that you would agree to start working tomorrow morning and do it weekly, okay? As usual, I'm hearing people tell us what we should be doing, but I'm not hearing somebody saying, I'm agreeing to hop on board and work with you starting tomorrow morning. I go to work tomorrow.
This is Yanni here. I will just
every
get
week.
hold of it.
Okay, John, I hear what you're saying. But it's what's happened with the expertizing is a lot of the stuff that Bill's talking about are old certificates when we all did things touchy-feely. No question about it. Back before the VSC 6000, we did stuff touchy-feely. It didn't feel right, therefore it can't be right. With the introduction of the VSC 6000, about 2012 for us in Toronto, from that point onward, everything has become analytical. It is no longer acceptable to say something doesn't feel right. And I'm looking at your particular cover. You have to be able to say why. Now, we don't put it on the certificate, but in the analytical process that we're doing in the meetings and with the VSC, what is, if it's not good, what is it? And how did it get there? All right, that's very much part of the process. It's changed huge over the last 10 years. I can tell you that. It's not touchy-feely anymore, not at all. Going to the extent of producing a 35-page document telling people what you did to get there, I don't see that happening, okay? There's an awful lot of volunteerism goes into expertizing. And, you know, this whole idea that you're coming up with requires about 10 people paid at least $50,000 a year to do this kind of stuff. And if you can find them in our hobby, I can tell you, you're a real dreamer. We're terrific for telling other people what to do, but not so good anymore at finding volunteers to get in there and work. All right. So that's my comments on it from somebody who's in there daily almost working at this stuff. Thanks, Ken. Bye-bye.
Thanks, Ted.
Yeah.
Gary, you're up again.
Just to follow up on Ted's comment, I had the opportunity, I guess the January right before COVID hit, to be up in Toronto at the Green, and absolutely fell in love with the methodologies that they employ up there, and I took those back with me to the APS. So the expertizing organizations have a lot to learn from each other. I do want to follow up though on the idea of having greater detail on the certificates. The challenge we face at the APS was that we actually have a guarantee that if our opinion is wrong, we're going to make the holder of that certificate whole if there is some financial damage. So we need to be specific in what we put on the certificate versus what we know but can't really put on a certificate. The approach I use and the approach I would like to see become standard throughout the industry is I issued a supplemental note which wasn't subject to any guarantee or insurance policy. and provided the notes, the details that were relevant in the issuance of an opinion, so that the recipient would understand at least how that opinion was formulated. But that wasn't necessary, and I'd say I did it in less than 10% of the certificates that I was responsible for ultimately issuing. So I would really like to see this become a more standard approach. I think it would be helpful to Bill's concerns.
Yep. Thank you. John Cebulskis, you're up.
Hi. Well, the talk was very interesting. And I was especially feel responding to Yanni's remarks. I entered stamp collecting at a late stage in my life as a very inexpensive collector of cheap stamps, because I didn't feel I could afford the kind that other people are talking about, and most of the ones that are talked about here are quite expensive stamps. Not all of them, but most of them. Paying a fair amount of money in order to, I should say that what I've been looking at mostly are early German stamps. Now, there are lots of color varieties here in the early German stamps, but few of them are worth amount to talk about, okay? We're talking about ranges of value going from maybe 50 cents to $10, okay, on varieties of stamp. And nevertheless, as a collector, I want to know the difference between them, and I want to be able to save one of each kind, okay? Now, what am I supposed to do? Am I supposed to send these to expertisers and pay what would be an exorbitant amount for me, okay, especially if I sent them 1,000 of them, okay, and said, can you find anything of any interest in here, okay? Or is there no help at all? And that's why I've been trying to use computers to help me to solve this problem.
That's a great question. And I want to go back to something that I've learned to do. There are instances where I have sought out enough experience to do my own, quote, expertization, end quote. I do my own work. Where, for example, if we were talking about inexpensive, readily available stamps with interesting color varieties that appear to be color varieties, if there's enough material out there in front of me on the table, I can group them into what appears to be a particular grouping. For that kind of thing, if we're not looking at a unique postmark or obviously a unique color, whether it's a changeling or is it something, we can do our own expertization to some degree. And I think we need to rely on our own experience. And then there is those experience of those in the stamp clubs and the chat boards, that there are other collectors that are more than willing to help and give their opinion. Lots of collectors, to be honest with you, they don't have a lot else to do, and so they're really happy to give an opinion, right? So it's something that I've done. I know in early Persia is really tricky, and I've tried to learn enough about it so that I can go to a certain point and say, I feel comfortable enough with what I know to say that this is good enough. And then if there's something really special, a very difficult item, then I might send that off for a certificate. But not everything has to go for a certificate. You know, our own knowledge and experience has a lot of value.
Well, I hear you talking, but how do you acquire the knowledge if you can never see the stamp? That is, if you don't have a copy of a stamp that you can be certain is a particular variety, how can you tell if you have others of it or not?
I was back and forth is just, I would suggest reference collections, other collectors that they have in their collections. Do they have copies for you to look at? We are, as collectors, we are hunting for items all the time. And whether we're hunting items to add to our own collections or looking for items for the sake of comparison and discussion, it's another purpose, but it's the same hunt. That's what I do.
Yeah, well, okay. I understand what you're saying. I don't have any other stamp collectors that I know of within 50 miles, except for my brother who lives about 50 miles away. And who I don't get to see as often as I'd like to as a consequence. But it isn't, and traveling all the time to different parts of the country, to different types of talks, the way many of you talk about that you do. Okay, not all of you, but some of you, and a good number of people from the German Philatelic Society travel all over the place and they expect everybody else to be able to do so. Okay. You come to the show and I'll show you some. You know, yeah, forget it. So it's still a problem for me, and still looking for a solution. Okay. And I've talked to several other people who were in this seminar, and we also have similar problems, not exactly the same, but similar. I'll leave it at that.
All right, John. I have one more hand up. Majid, do you want to join us?
Sure. I was just going to say, it seems to me there is a demand really for I don't think APS or Philatelic Foundation can accumulate all the equipment that everybody used in this seminar or symposium to basically do the analysis they did. That's just not what APS does, or what Philatelic Foundation does. And they cannot charge according to those things. But I do think from everything I hear, there is really enough demand for an expertizing service that uses very high-powered devices and can potentially charge for those things, if you have a $300,000 equipment, it is going to cost every time to use that. Now, if it is an expensive stamp, then the owner of that stamp will feel probably very much justified to spend, I don't know, $500 to check whether this is actually the genuine item or not. But like I said, it sounds to me there is really genuine demand for such a service. And I don't know if people who are here really do want to do it, but obviously people who are here are the best people to do it. That's how I see that.
One comment to make is that I just was going to say that after listening to the last few comments, and thank you, Majid, especially, I'll bet that after this symposium is concluded, I'll bet there will be discussions between members that may lead to something like this. It may just happen all by itself. So I think about the concept too of interlibrary loan, to where one library doesn't have a resource and they go to another library to get it. And there may be where there are cooperative agreements between organizations that offer expertization services to where these services could be provided on an exchange basis. There's a fee structure, there's a contract, there's something that guides that cooperative agreement, but it could certainly be there.
Just to point out to the people on this call who may not know, I've now had from two different people, let's call it a price offer from Foster Freeman for a refurbished VSC 6000, which is thus one generation old. And that refurbished machine is $20,000. So yeah, you don't want to be expertizing 50-cent stamps with a $20,000 machine, let alone the cost of the person sitting in front of it. So clearly that has to be a factor in the decision, and we could keep Foster Freeman alive by the whole hobby buying a bunch of these machines, but it's not practical. We'd rather have the stamps than the machines, right? I've got Louis Morell in with another question. Louis, go ahead.
Thank you. This question is not necessarily just for you, Bill. Others may have some comments or thoughts about this. I had never heard of Maria Brettel before, and I had to look it up. Turns out she's a German expertizer. So my question to you and the rest of the group is it commonplace for an expertizer to print his or her name in the back of an item? And I know that doesn't deface the stamp, but it does alter it from its original state. So is this common?
There is a website to go to. It's fascinating. It's called Philatelia.fi. It's Phila, Philatelia, Philatelia.fi. It's based out of Finland. It is a library of philatelic expert marks applied to the back of stamps since the beginning of philatelic time, identifying most of those marks and giving a biography as to who applied them. The early expertisers signed their names as a way to put their reputation on the line. Quite often dealers, Zenf in Leipzig, dealers in Berlin and Paris were very commonly applied their markings on the back to say, we put our name on the line that this is the real deal. The only time it really defaces a stamp, in my opinion, is when that ink by chromatographic separation bleeds forward into the front of the stamp where it's visible, and that has happened on some of them. But those in the back are very commonly done. And quite honestly, I place some value when some of these that are not known to have been forged. By the way, these expert marks are also forged, but some of them are not known to have been forged, according to information available to me on the internet. But that to me adds a lot of credibility. Some of Max Tier, some of those guys, I don't remember if Max's was forged or not, but a very tiny little mark in call it a Germanic font in magenta ink. It's very tiny, and some people miss it; they don't even see it. So they're on there. One of the stamps in my collection has the bold signature of the of a very famous Italian baritone on the back, and so there's a lot of history in that marking on the back, and it was commonly applied. More recently, Sergio was still signing his name very carefully to the back of the stamps until his passing. But many times the stamps themselves are not marked today as often as they were early on.
I think a big factor in that was in some countries it was illegal to photograph the stamps. In practice, it was expensive and no good way to create what we now expect as a photographic certificate or a scan, even more common now. So the initials on the back of the stamp were simply the only way the expertizer could tie his opinion to that particular stamp. And a lot of them used pencil and not a little hand stamp. It just depended on who it was.
We also have to be careful that a mark on the back of the stamp is not necessarily that of an expertizer.
Right.
More often they're the mark of an owner. So we have to be careful. Did the owner actually know what they were doing, or were they just saying, this is my property, in case it gets stolen, I want it back?
Yep.
Thank you.
To go back to my previous comment, Ted Nixon said that the Green Foundation is looking at a VSC 8,000 and the cost is close to $100,000. And you know what? It doesn't matter whether that's Canadian or US dollars. It's a lot of money. I had one more in here too from Joe. There we go. Joe?
Right. I'm a lapsed philatelist. I switched into paper money about 50 years ago. And I teach a course in counterfeit detection of worldwide paper money every 2 years at the ANA Summer Seminar in Colorado Springs. I have a hard time filling that course every time I offer it. And once they canceled it because of not enough people in it. A couple times I've had only 2 or 3 people in it, but it's been underwritten by some other numismatic organizations. I would welcome some stamp collectors in there because a lot of the analysis is transferable. You know, it's all printing technology, inks on paper. And there's lots of stuff that you can pick up in a counterfeit paper course that would be applicable to stamps.
Agreed. Good commercial.
Next time I'm offering that is next year. I have 3 more days to get my prospectus put together and send into them, but I'm sure that they will offer it. Whether it'll teach it or not depends on how many people sign up. It'll be next June.
Send that to IAP and we can circulate that to our membership.
Okay.
All right. Our queue is down to nothing. So I am going to adjourn the 5th International Symposium on Analytical Methods in Philately. It's been a great pleasure to have all the scientists, the writers, the speakers, the last October 10th and today the 17th. I appreciate the work that's gone into this. I want to thank Tom Lira, John Barwis, and Ken Tretton for all of the effort they put into this as well, behind the scenes editing and getting the papers together. Ken Tretton puts together the book and gets it off to the publisher. So there's a lot of behind the scenes effort that goes into this. Thanks to everybody who came virtually and listened to us over the last 2 days of presentations. It's been a lot of fun. And if you have ideas or suggestions for the next one, by all means, visit the analyticalphilately.org website and send them to us. We appreciate them very much. With that, we are adjourned.